boys and girls. In the last video of powers and exponents, we have seen the different formulas that are involved in the powers and exponents. The powers and exponents, the chapter is also called indices. Number is said to be written in indices form when we have a base and also power to it. So, for example, if a number is written like x to the power of n, where x is the base and n is a power, which means the x is multiplied by itself for n number of times. So this number is said to be written in indices form. So there are various formulas that we have derived. Some of them we derived and some of them we said like there is no need to derive, but the only thing is that you have to remember. For example, x to the power of 0 is a 1. That is a kind of identity, and we don't need to prove in high school maths, but you have to remember that x to the power of 0 is equal to 1. Yeah, the various formulas are x to the power of a by x to the power of b is equal to x to the power of a minus b. For example, if something written like this, 3 to the power of 8 by 3 to the power of 7, which is equal to, can also be written as 3 to the power of 8 minus 7, because there is a division and both the numerator and denominator both are having the same base. In this case, 3 is the base, and if you see some fraction like this, it can be written like this. It's going to have the same base. So in this case, the base is 3, and we're going to retain the same base, and we have to subtract the denominator from the numerator. So in this case, 3 to the power of 8 minus 7, which is going to be 3 to the power of 1, that is going to be 3. Okay, so that's about x to the power of a by x to the power of b, and the other formula is x to the power of a into x to the power of b is equal to x to the power of a plus b. Okay, for example, 2 to the power of 5 into 2 to the power of 6 is equal to 2 to the power of 5 plus 6. Again, the very important thing is they should have the same base. In this case, the base is 2, and the answer is going to be 2 to the power of these powers here has to be summed up. Okay, here it is a multiplication, here it is a sum. Okay, yeah, this is going to be 2 to the power of 11. For example, if a number is written like this one, some expression is written like this one, it is not going to be 2 to the power of 11. Okay, so there is a difference here. Here there is a multiplication taking place, and here it is an addition. Okay, so you have to be careful what is here. There is no way that you can simplify this one. There is no shortcut. You have to evaluate this one, and you have to evaluate this one, and after that you have to sum it up. Okay, so that's only the way you can simplify this one. And similarly, 1 to the power of n is equal to 1. That n can be anything. It can be a fractional number, it can be 0, it can be 100, it can be 200, it can even be minus numbers like a negative numbers. Say for example, 1 to the power of minus 100 is equal to be 1. 1 to the power of 0.5 or 1 by 2 is going to be 1. Okay, and we also proven last time how we derived this one, how we got this answer. Okay, and the next one is x to the power of 0. That's a kind of identity that you have to remember. And x to the power of n is equal to minus x to the power of n is equal to minus x to the power of n if n is an odd, or is whose value is also going to be x to the power of n when n is an even number. Okay. Yeah, this also we derived it, and x to the power of 1 by n is equal to nth root of x. For example, x to the power of 1 by 5 can also be written as fifth root of x. Okay, for example, take an example, 8 to the power of 1 by 3 can be written as cubed root of 8. Okay, or 27 to the power of 1 by 3 can be written as cubed root of 27, which is going to be 3. Like if you multiply 3 by itself for 3 times, you get this number that is under the root. Okay, in this rate it is in this case it is a cubed root. Yeah, this is how you have to evaluate it. And similarly, there is also another formula where x to the power of minus n is equal to 1 by x to the power of n. For example, if something is written like this one, a to the power of minus 1 by 3, it should be written as 1 by a to the power of 3. Okay, and again you have to figure out what is the value of 8 to the power of 3, 8 cube, which is also can be read as a 8 cube, and you find out the value of this one and you put that value here and then simplify, or if you need it in a decimal value, use your calculator and find out what the decimal value is. Okay, and last one that we found is 0 to the power of n is equal to 0. Again, n can be anything. N can be anything. Say for example, 0 to the power of 100 is going to be 0. 0 to the power of minus 8 is going to be 0. Okay. Yeah. So these are the things briefly I just summed up whatever we discussed in the previous video. So in this video, we're primarily going to look into the simplification part of a number or an expression written mainly in the indices form, the simplification, and the comparison of numbers that are written in indices form. Okay. So let's take an example. 3 to the power of 5. This is one number, and the other number is 3 to the power of 8. Which number do you think is the bigger? Obviously, it's going to be 3 to the power of 8, because in this case, we are multiplying 3 by itself for the 8 number of times. Obviously, this is going to be bigger. So if you put a comparison box in between, so this is going to be bigger. Okay. Yeah. So I'm gonna like 3 to the power of 5 is 3 into 3 into 3 into 3 into 3. 3 to the power of 8 is 3 into 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 3. Okay, so there are 8 number of times that they are multiplying 3 by itself. Okay, so yeah, obviously this is a bigger. That's fine. Okay, so okay, we've discussed it. I'm going to keep it like this. Okay, so here if you see, the bases are same. In both the cases we have the same base. Okay, and the powers are higher. So for this number we have a higher power, that is 8. So we're telling that 3 to the power of 8 is bigger than 3 to the power of 5. That's fair enough. Okay, that's very simple, very straightforward. Okay, fine. So I'm going to take another number. That number in this case is going to be 1 to the power of 5, and the other number is 1 to the power of 8. So now in this case, what is the bigger one? Can you tell? Yeah. So in this case, both the numbers are same, because we have to apply this formula. 1 to the power of n is equal to 1. So no matter what we have for the value of n, it's going to be, it comes to 1 only. Okay, so if you put a comparison box in between, it's going to be is equal to. Okay, it's going to be is equal to. Okay, yeah. Regardless, it can be 5, it can be minus 5, or here it can be 8, or it can be minus 8, or 1 by 8. So no matter what we have, so we get the same comparison symbol between these two values. Okay, see, it's giving a different results. In this case, the bases are same. Here also the bases are same, but here the power is higher. So this number is bigger than this number. That's why we take less than symbol here, and in this case we put an equal symbol, because both these indices numbers, when you evaluate, both of them are equal to 1. This side is equal to 1 and this side is equal to 1. See, you're getting a different results here, and depending on the base, the comparison symbol is varying. Here in this case it is less than, here it is equal to. So in both cases the powers are same. In both the cases, the powers are same on the left side and the right side, and here also on the left side and right side we have the same base. And yeah, and I'm going to take another example. For example, 0.1 whole to the power of 5, 0.1 whole to the power of 8. So which one is going to be bigger in this case? Yeah, it's very tricky. Okay, so if you multiply, so if you evaluate this one, you can use your calculator, or you can simply multiply it. So you get 0.00001 here on the left side, because its power is 5, and you have to put the decimal point after 5 places from the right. Okay, and this is going to be 0.000000567. This is how it's going to come. Yeah. Okay, so there are 8 places: 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So which one is the bigger? So this is equal to this one, and this is equal to this one. Which one is bigger? So this is bigger. Okay, so I'm going to put this one again here. So we come to some conclusion. I'm going to derive some conclusion based on these various calculations that we are doing here. Okay, all right. Okay, so if you notice all these things, so this is going to be bigger. Okay, this is going to be bigger. Yeah. So in both these three cases, we have the same bases on the left side and the right side, and the powers are also same here on the left side, and on all the left sides we have the same powers, and on the right sides we have the same powers, but the comparison symbol is varying. You know why it is varying? It is primarily because of the bases that we are picking up here. Here the base is more than 1. If a base is more than 1, whichever number is having the higher power, that number is obviously the bigger. It should be more than 1. Okay, it should be more than 1. It's even 1.1 is also, you can this formula holds good for 1.1 also. Okay, anything more than 1, and if the base is 1, this is going to be equal to, no matter what we have for power, it's going to be the whose value is going to be 1. So in this case it is going to be equal to, so if it is less than 1, and if it is less than 1 and more than 0, so in this case I have taken 0.1 as the base, and it's raised to the power 5 on the left side, and it's raised to the power 8 on the right side. So we have this number is more than this number. So the number whichever is having the lower base is greater, and whichever is the number having the higher base is the lesser, when you take a base between 0 and 1. Okay, between 0 and 1. Again, this varies, and if you take a negative numbers, for example, I'm going to take the same, okay, minus 3 to 5, yeah. Okay, so I've taken minus 5 as a base here, and minus 5 as a base on the right side. Yeah, on both sides I've taken minus 5 as a base, and here I'm cubing, and here to the power of 5. So this is an odd power, so we'll get a negative number on here this side, and we'll also get a negative number on this side. So if you simplify this one, which formula am I using? The formula that I'm using here is this one. Okay, minus x to the power of n is equal to minus x to the power of n when n is odd. In both the cases the powers are odd. Okay, so whose value is going to be minus x to the power of n, so which is minus 5 to the power of minus 5 cube, and on the right side also you see minus 5 to the power of 5. Okay, so on both sides we have a minus symbol, that's fine, but whose value is bigger, 5 cube or 5 to the power of 5? Obviously this value is bigger. Since we have a negative symbol on both sides, this is going to be effectively, this is the bigger number. Okay, this is the bigger number. Again, it's not always the same, depending on the powers that you are taking. Okay, for example, here I took a 3, and if I took 6 here, the symbol is going to be this way. Okay, so you have to be careful, and just don't go by the powers. It's not necessarily always true that if you have a higher power, that number is going to be bigger. It's not always be true, and the behavior of the indices number will vary depending on what base that you are taking when you are comparing the numbers, especially. Okay, yeah, that's how you have to be careful. But there's one rule. One rule is that say say for example 23 to the power of 5, and on the other side you take 23, sorry, on the other side you take a 5 to the power of 23. Okay, so if you notice the pattern closely, I have interchanged the powers and bases from left side to right side. Here the base is 23, here the power is 23. On the left side the power is 5, on the right side the power is on the right side the base is 5. So yeah, there is one formula. That formula is that if you interchange the powers and bases, whichever side you have a higher power, that number is bigger. Okay, higher power, that number is bigger. But there is also a condition. The numbers that you are taking here and as a base, as a power, should be more than 3. Should be more than 3. So the reason why I am saying more than 3 is that, say for example, if you take 2 to the power of 2 cube on the one side, and if you take a 3 square on the other side, so which one is bigger? So in this case 2 cube is 8 and 3 square is 9. So which one is bigger? This is bigger. Though we have a lesser power here, this number is bigger. So that is why I clearly said that it should be more than 3. Both the bases and the power should be more than 3. Then only this formula holds good. The formula is that if you want to compare two numbers that are written in indices form, and for both these numbers the bases and powers are more than 3, if that condition is satisfied, whichever number is having a higher power, that number is a bigger. Say this is how, for example, I'm going to take another one. It should be more than 3. Okay, don't mix up with the negative numbers or anything. Okay, it's not going to hold good for 0, it's not going to hold good for 1, it's not going to hold good for 2. Okay, the numbers that you're taking should be more than 3. Okay, you should not even take negative numbers. Okay, so I'm giving another example. Say 73 to the power of 82 and 82 to the power of 73. So which number is bigger in this case? Okay, so if you apply this rule, both are more than 3. On the left side the base and the power is more than 3, on the right side the base and the power is more than 3. So this condition is satisfied. So whichever side we have a higher power, that number is bigger. In this case 82 is a bigger, so it should be this way. So okay, 73 to the power of 82 is greater than 82 to the power of 73. Okay, so this is another formula that you can establish. Yeah, in general, this is how the comparison between the two numbers that are written in indices form works. Okay, you should be careful, like there is no single formula that you can derive, but depending on what you have taken as a base, depending on what you have taken as a power, the value, the effective value of that indices number varies. So you should be very careful, and yeah, it's very important that this drastically varies if you take numbers that are, if you take a basis as a number between 0 and 1, for example 0.1 in this case I have taken, so the results is going to come opposite. So here we have a lesser power, but this number is bigger one. Okay, so on both sides we have 0.1 as the base, and this side we have a power 5, and this side we have a power 8. Still this number is a bigger, which the base that is having that is having a lesser power. Okay, so that's how it's going to be. There's no single formula, but you have to practice, take some numbers that are written in indices form and compare it yourself and see what kind of patterns they are following. But this is how the pattern usually. If you take the numbers more than 1, this is how it's going to work. And if you take the number like the base is 1 on both sides, then this is how it's going to work. And if you take a number between 0 and 1, this is how it's going to work. And if you take a negative numbers, again it varies. I already showed you some of the examples with the negative numbers. Yeah, that's how it's going to work. Okay, yeah, so comparison, but these are all the primarily the main formulas that you must remember and you have to apply wherever. the situation demands. Okay, the comparison part we have seen. We'll also see simplification of the numbers that are written that are given in indices form. Okay, I'll take some examples. I've written some of them here. Say for example, x to the power of m into x to the power of n by x to the power of 0. Okay, if an expression is given like this, and if you're asked to simplify this whole expression and give the simplest form, then what you have to do is that you have to see like whatever formula that you can apply. You have to see whichever is a more suitable formula here in these given formulas, and you have to apply that formula. So in this case, the x to the power of m into x to the power of n. So the closest formula for this one is x to the power of a into x to the power of b is equal to x to the power of a plus b. The same formula you can apply x to the power of, if you simplify these two, you get x to the power of m plus n by x to the power of 0, whose value is 1. Whose value is 1. Okay, so this is how it is, and any number with the denominator 1, you'll get the same number. So this is going to be x to the power of m plus n. Okay, so when you simplify this whole expression, we got this one, x to the power of m plus n. Okay, so I'm using the x's here. So for example, they may ask like 2 to the power of 5 into 2 to the power of 8 by 2 to the power of 0. If you're asked to simplify this one, you have to apply again the same formulas like whatever we did here. The same, you can use it here. 2 to the power of 5, 2 plus 8, because here there is a multiplication and the bases are same. That's two key things, like bases are same and there is a multiplication taking place between these two numbers. In such case, you can sum up the powers, and 2 to the power of 0 is 1. Anything to the power of 0 is 1. Okay, so when you simplify it, this can be 2 to the power of 13. Yeah, you can leave it up till here, or if you want to find out, you can use your calculator and find out the exact value of 2 to the power of 13. Okay, so that's one simplification that we have seen, and then also do one more simplification. X to the power of m plus n whole square by x square to the power of m. Okay, let's see how to simplify this one. Let us see. Okay, so which formula that you're going to use? Yeah, it's the one formula that I forgot here. X to the power of a whole to the power of b is equal to x to the power of ab. Okay, so this is also another formula where we have seen in the previous video. Okay, say that's one formula. Yeah, if expression is given in this format, and if you are asked to simplify this whole expression, and if you are asked to write the simplest possible form of this whole expression, this is how you have to do. So what is the formula that we can apply here? So this is the formula. So x to the power of something to the power of some other thing. Okay, this one you can consider as a, this one you can consider as a b. X to the power of a whole to the power of b. So that's going to be x to the power of ab. X to the power of ab. We are simply multiplying it here. So in this case, what we have to do, multiply m plus n with 2 by, again here also the same, x to the power of a whole to the power of b. This one you can consider it as a, and this one you can consider it as a b. So okay, so the simplest form of this one, when you apply this formula, you will get it, x to the power of 2m ab. This is a, this is b, and yeah, so when you multiply both of them, you got the x to the power of 2m. Again, you further simplify this one, x to the power of this, you can expand it to 2m plus 2n, because 2 is multiplying both m and n. 2m plus 2n, 2 into m, 2m, 2 into n, 2n, and there's a plus here, by x to the power of 2m. Okay, yeah, we can even further simplify this one. No, right here only. So x to the power of 2. So which formula you are going to apply it again here? So x to the power of a by x to the power of b, which is going to be x to the power of a minus b. That formula you can apply. The whole thing you can consider as a, and this thing you can consider as a b. So in this case, x to the power of a minus, this is all, the whole thing is a, and this part is b, 2m. Okay, now this here it is a plus 2m and here it is minus 2m. You can cancel out these two and you are left with x to the power of 2n, x to the power of 2n. Yeah, okay. Yeah, so when you simplify this whole expression, you got an answer of x to the power of 2 to the power of n. Okay. Yeah, the simplification is mostly, how you are able to apply these formulas of powers and indices. Yeah, mostly these are only the formulas, but we have to see like at what stage you have to, at what type of formula that you have to apply for the given situation and given condition. Okay, so this is the expression that is given, and when you simplify it, you got x to the power of 2 to the power of n. Okay, so you may be asked to find out what is 100 to the power of 0. Again, the same formula that you can apply. X to the power of 0 is equal to 1. Okay, so that's how they can ask you to find out like what is the value of 100 to the power of 0, and similarly minus 1 to the power of 8, what is the value of this one. Okay, so which formula are you going to apply? Yes, you can apply this one. Okay, so n is an odd, n is an even number, so minus x to the power of n minus x whole to the power of n is equal to x to the power of n, and n is an even number. In this case 8 is an even number, so the same thing we can write it as 1 to the power of 8. Okay, we can eliminate this minus symbol here, so we eliminated here. The answer is either this one or this one, depending on what the n is. In this case, if n is an odd, this is an answer, and if n is an even number, then this is an answer. Okay, so n in this case n is 8. Okay, so that is an even number. So the answer, we can write it like this, 1 to the power of 8, which is going to be 1. Okay, so then I ask you to simplify what is the value of minus 1 whole to the power of 8. The answer is 1. Okay, so the questions also can be asked like this. You simplify this one, simplify this fraction. Okay, and the numerator we have a minus 10 whole to the power of 8 again, which is in this part, which is in this format, and yeah, because 8 is an even number, the answer is going to be x to the power of n. In this case, we can get rid of minus, and the numerator, when you simplify it, you get 10 to the power of 8, and the denominator is 10 to the power of 7. Okay, there's another formula that you can apply here. That formula is this one, x to the power of a by x to the power of b is equal to x to the power of a minus b. Okay, so when you apply this formula, in both cases we have the same base and a different powers, and there's a division in between these two. Okay, so okay, the simplified form is going to be x to the power 10 to the power of 8 minus 7. Okay, there is a division here, and when you simplify it, when you apply that formula, those powers 8 and 7, there is a subtraction taking place, numerator minus denominator power, numerator power minus denominator power. In this case 8 minus 7, which is going to be to the power of 1, and again there is a formula that you can apply here. 1 to the power of n is equal to 1. That is one of the formula, but the other formula is, say for example, x to the power of 1 is equal to x. This one also we have discussed in the last session. So anything to the power of 1 is equal to that thing only. In this case, x 10 to the power of 1 is equal to 10. Okay, so when you simplify this one, we got 10. Okay, this is how you have to do simplification. Okay, so another sum that we're going to do here is that 16 to the power of 5 into 4 to the power of 8 by 2 to the power of 4. If you're asked to simplify this one, the number of ways you can do it, but yeah, the preferred way is that you bring all these numbers into the same base. Here we have a base of 16, here we have base of 4, here we have a base of 2. what is the lowest base here in all these three numbers? Like this is one number written in indices form, this is another number written in indices form, and this is the another number. So what is the lowest base out of these three numbers? The 2 is the lowest base. So you bring all these numbers into the same base. Same base is in here, the lowest base is 2, and bring this number also into as a 2 to the power of something, and this number also you rewrite as 2 to the power of something. So if I rewrite this one as a 2 to the power of something, this is how you have to do. So 16 can be written as 2 to the power of 4. Okay, I have removed 16 and put 2 to the power of 4 in place of 16, and I'm going to apply this power again. Okay, there is no change to it. Okay, here it is 16 to the power of 5. Instead of 16, I've written 2 to the power of 4. Okay, and here 4 to the power of 8. The 4 also can be written as a 2 square. Okay, the 4, I have removed 4 and put a 2 square in place of 4, and to the power of 8 will remain as it is. There will not be any change. Okay, by 2 to the power of 4. I'm going to keep this number as it is because this is having the base 2. The whole purpose of doing this step is that I wanted to bring all these numbers, like there are 3 numbers associated here, like this is one number, this is one number, this is one number. All these numbers are in indices form, but I want to bring all these numbers as a common base. Okay, okay, let's see. I did not even get the scope for further simplification. So if I simplify this whole number, which formula are you going to use here? X to the power of a whole to the power of b is equal to x to the power of a. So if I apply that formula, you will get 2 to the power of ab. Multiply both these ones. 4 5s are 20 into, again the same formula you can apply, x to the power of a whole to the power of b is equal to x to the power of ab. So 2 to 2 square whole to the power of 8. So when you simplify it, you will get, multiply these two, 2 and 8, you get 16 by 2 to the power of 4. Okay, yeah. See, here we have a base of 16, we have a base of 4, we have a base of 2. Okay, from this step we came to this step, and from this step we came to this step. Okay, and this step, if you notice closely, for all these 3 numbers we have this common base, that is 2. Now it's easier to simplify. Whenever you bring the numbers into common base, the multiplication part is easy and the division part is easy, because these are the 2 formulas that you can easily apply. Here this is a division, here this is a multiplication. If you simplify this numerator, you can get 2 to the power of, right on the right side, 2 to the power of a plus b. There's multiplication here, and we have the same basis, so it's going to be addition here, 20 plus 16 by 2 to the power of 4. Okay, if you further simplify, 20 plus 16 is going to be 2 to the power of 36. 36 by 2 to the power of 4. Okay. So if you further simplify again, you can apply this formula. Which formula? This one. X to the power of a by x to the power of b is equal to x to the power of a minus b. So 2 to the power of 36 minus 4. A minus b. So I'm considering this as an x because both the numerator and denominator we have the same base. This is a and this is b. A minus b. Okay, if you further simplify this one, 2 to the power of 32. Yeah, if you leave it up till here, that's good enough. So this whole expression associating 3 different numbers with the different bases and the different powers, we brought to the single indices number. Single number that is written in indices form. Yeah, if you leave it like that, that's fine. And if you still want to find out the exact value, you can use your calculator and figure out what that value is. But mostly in examination, what the examiner usually expect from you is that whether you are able to bring this whole number to this form or not. Okay, if you do it, that's more than enough. Yeah. So something like this may be asked in examination. It's not actually simplification, but there is some kind of a fill in the blank sort of thing here. So you need to fill what this is going to be here. Okay. Okay. So let's see. Let's assume this the value here is an x, which is not known to us at this moment, and we need to find out what that x value is. For now, let's consider that as next. Okay. So I consider this as next. So this is going to be x to the power of a whole to the power of b. Which formula we're going to apply here? X to the power of a whole to the power of b is equal to x to the power of ab. So in this case, 2 to the power of 3x. I need to multiply these two. X into 3 is equal to 3x. X into 3 is equal to 3x. Here it is 16 to the power of 5. Okay. So can we derive anything from it? No, we cannot derive it because here we have a base of 2, here we have a base of 16. So you cannot compare the powers. You cannot compare the powers. There is no relation exists between the powers because we have a different bases. So when you land up in this situation, what you have to do is that you bring both into the common base. Okay. So what is the simplest way? Like 16 can be written as a 2 to the power of 4. 2 to the power of 4. 16 I have written this is 2 to the power of 4 and I put whole to the power of 5. This power of 5 remain as it is. The only thing is that I taken out 16 and I put it 2 to the power of 4. Okay. The reason why I am doing is that I want to bring both into the same base. Here we have a base of 2 and here also if I further simplify I'll get say AB. 4 5s are 20. Okay. See here we have a 2 to the power of 3x and 2 is equal to 2 to the power of 20. So what this tells us is that we have a same base on both sides and the powers, there is some unknown quantity on the one side and there is a known quantity on the other side. So the powers we can equate it in this case. So when you equate it, 3x is going to be 20. Okay, so I am equating this part to 20 and so if I further simplify, we get 3x is equal to 20, x is equal to 20 by 3. Okay, that's an answer. That's an improper fraction. But if you want to do it, it's going to be 6, 2 by 3. Yeah, that's a mixed fraction. Just a mixed fraction. Yeah, it can be. It can be in fractional values. Okay, because this is what we said, right? X to the power 1 by n is equal to nth root of x. Nth root of x. Okay, it can be in mixed fraction. There's no doubt about it. Like we're dealing with the powers and indices, but the base can be in fractional form or the power can be in the fractional form. Say for example, if something is written like 2 to the power of 20 by 3, how are you going to write it as 2 to the power of 20 by 3? The way you can write this as, look at carefully, 2 to the power of 20 by 3. So this can be written as 20 to the, 2 to the power of 20 by 3 can be written as 20 into 1 by 3, isn't it? Okay, 20 into 1 by 3. Okay. Now, because of this 1 by 3, because of 1 by 3 on the power, in the power, we can do this as cube root of 2 to the power of 20. So which formula am I applying here? So this is the formula that I am applying here. X to the power of 1 by n is equal to nth root of x. There is a 1 by n here. That is this number 1 by n. Okay, because of that 1 by n in the power, we can rewrite this number as cube root of 2 to the power of 20. This 2 to the power of 20 as it is, we can keep it under the root, and because of this 1 by 3 in the power, we can put this whole number under cube root. Okay, cube root of 2 to the power of 20. Yeah. So what I mean to say is that x, in this case we got is 20 by 3. That's fine. Like it can be a fractional number, it can be a decimal number, it can be a negative number, it can be a positive number, it can be anything. Yeah, it can be 0, it can be 1. Okay. Yeah. Okay, I have shown you few examples as how to simplify the expressions that are given in indices form. Mm, yeah, that's pretty much it. Like, yeah, you practice more and more from your textbook, and you get some fair understanding. Like, you get more and more practice, so that it will be easy for you to face the exam. Okay, so another thing I want to, this comparison we discussed and the simplification we discussed, and another thing that I want to discuss is that scientific notation. Scientific notation. Writing a number in a scientific notation. Okay, so in the universe, you see numbers like there are things that are very, 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 very small, and there are things that are very, 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 very big. For example, if you take the mass of the Earth, which is quite a many thousands of kgs. Okay, if you take the mass of the electron, which is very, 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 very small. Okay, so for example, if there is a number like 36 0 0 0 0 0 0 0 kgs. Okay, it's so difficult to write such numbers. The first problem is that it is occupying too much of space, and second problem is the zero is keep on repeating for a number of times. What all those, how many times is it repeating is uh, it's very difficult to count. Like if you're counting it from afar and from a little distance, there's always a possibility that you may make a mistake, and instead of putting five zeros, you may put six zeros. Instead of putting seven zeros, you may put nine zeros. Like that, those things can happen. So that is for this reason the scientific notation is very much helpful. Scientific notation is is if a number is written in a into 10 to the power of n, then that notation is called a scientific notation. Okay, a can be a can be any number between between is between 1 and 10. Okay, between 1 and 10. To be precise, a should be less than 10. It should not be 10, but it should be less than 10, and it can be 1 or more. 1 or more. Okay, a should be between 1 and 10. It should not be 10, it should be less than 10. It can be 1, but between these two numbers it should be like 1 is less than or equal to a is less than 10. Okay, that's what the a should be. And n can be 0, or n can belong to n, like any number, a positive number or a negative number, a whole number. Okay, it should not be in a fractional form. It should not be like 1.5 or 0.5 or minus 1.6 or minus 2.5 or minus 20.6, like that. Okay, it should not be any a decimal number. It should not be any decimal number. Okay, so if a number is written in this form, a into 10 to the power of n, where a value lies between 1, like 1 is less than or equal to a is less than 10, and n value either it should be 0 or it should be some integer value, a positive integer or a negative integer. For example, if some celestial body, some body in the universe whose mass is this much, or it could be even bigger. Yeah, for example, you put two more zeros here. Okay. Okay. So it's very difficult. It's very difficult to count how many zeros you have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros in this case. But say, for example, if you are reading this number from a little far distance or little distance, then there's always a possibility that you may make a mistake in counting the number of zeros that we have here. Okay. Say, let's write this one as a scientific notation. In a scientific notation. Okay, so the very first thing is that here we have 3 6 followed by 10 zeros. Okay, 3 3 3 3, yeah, and 1, yeah, we have 10 zeros here. So a should be between 1 and 10. So in this case, what you have to do is you pick up this number like 36, you put a decimal between these 3 and 6, Okay, the reason why I'm picking 3.6 is that it should be between 1 and 10. So 3.6 is only the number. 3.6 is only the number that is uh, between 1 and 10. That's why I've chosen 3.6. The reason why I'm choosing 3.6 is that I moved my decimal point. So if there is no decimal point explicitly given, then the decimal point usually lies here. Okay, so I moved it, and I kept here the decimal point and I left it there. Okay, so I kept a decimal point here, so I got a 3.6 into how many places you moved your decimal point to the left. How many places you moved your decimal point to the left. How many places? Say here it is. Okay, if there is nothing given, this can be written as like 0.0. That means the decimal point, the location is here. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 places you moved your decimal point towards left. Towards left. If you move your decimal point to the left, you have to write 10 to the power of, in place of n, you put 11 here. Okay, so this number like 3, 6, and after that 10 zeros, 10 zeros. This 0 is not there originally. I put a 0 here just to represent the decimal point. 3, 6, after that if there are 10 zeros, that number can be written as this, can be written as this way, and this number is said to be written in scientific notation. See, if you compare it to this format, a 3.6, that's fine, this condition is satisfied, and n is 11 here, and n is a whole number, n is 11, n is 11 here, so that condition is also satisfied. So this given number, I have written this into scientific notation. Okay, yeah, so a celestial body weighing this much kg, if you want to represent this in scientific notation, this number, you can write it as this way, and this is easier to read. 3.6 and 10 to the power of 11. Very easy to read this number. Okay, there is no mistake will go like this, always a less than 10 and more than or equal to 1, and this one is going to be whole number. So the 11 is easy to remember, 5 is easy to remember, 6 is easy to remember, easy to write also. It's not taking that much space. Again, there is a lot of space is required here to write, and there's not much space required. Okay, fine. This is a bigger number, like 3, 6, and after that there are 10 zeros. So we have written it in scientific notation. Say I'll take another number. Say I'll take another number which is 0.000063, 0.000063, say meters. Okay, some maybe electron, or even some bacteria, or you pick up any minute body in the universe, and whose length or whose breadth, whatever, yeah, is this much, 0.00000063 meters. So if you want to convert this one into scientific notation, can we do it? Yeah, we can do it. This is the smallest value. It's very small, very smaller than 1. It's very small, smaller than 1, and this value is more than 0. Okay, and if you want to write this one into scientific notation, again, the scientific notation, the general format of scientific notation is a into 10 to the power of n, where a should be between 1 and 10, and n should be either equal to 0 or should be equal to any whole number. That number can be a positive number or a negative number. Fine, yeah. Let's write it. So previously we moved our decimal position to the left. And this case we have to move it to the right, because you have to achieve a that should be between 1 and 10. So in order to achieve that a, you have to move your decimal point to the right. Say I moved here. So am I getting a between 1 and 10? No. I need to further move it, further move it. Even if I left it here, I'm not getting more than 1. Okay. If I leave my decimal point here, then it's going to be 0.63. That's not enough for me. What I want is that A should be more than 1. So I'm further moving my decimal and leaving it here. Then what are we getting as A? Is 6.3. My condition is satisfied here. Okay, so that's 6.3. I'm putting it here in place of A. In place of A, I'm putting it 6.3 into 10 to the power of, what is that 10? Previously, we moved our decimal point to the left. Okay, in that case, we put a positive number, 10 to the power of 11. We put in the previous example. In this case, we moved our decimal point to the right. How many places we moved? 1, 2, 3, 4, 5, 6 places we moved. So in that case, you have to say 10 to the power of minus 6. You move to the right. That's why I put you kept a minus 6. Okay. Again, don't forget to put your units as usual. They are very important. Okay. So don't miss out the units. And that small tiny particle, it can be bacteria, it can be virus, it can be electron or proton or neutron, whatever it is, whose diameter or whose radius or whose uh, perimeter or length. If it is written this way, that is given as this way, the scientific notation of representing the same number is 6.3 into 10 to the power of minus 6 meters. Okay. Yeah, this is too small, and the previous one is a too big number. This is too small. Yeah. Those such a big numbers, you can write it in a simplified format, and this format is called a scientific notation. It's very important. Yeah, you practice few more. Let's quickly practice a few more things, few more examples. For example, if something like 5600. Yeah, it need not end with zero. Okay, the previously we have taken some 0000. For example, if something like this 7823. If something is written like this, and if you are asked to convert this whole number, say you put this one as a kg, you are asked to convert this one into scientific notation. What you have to do is that the decimal lies here, because this number can be written as 823.0. Okay, the decimal lies here. What you have to do is you have to move your decimal to the left. Why am I moving it to the left? Why not to the right? Because this number is already bigger. It's more than 10. It's far more than 10. So there is no point moving it to the further right. One option that you're left with is to move that point to the left side. So I'm moving it. See carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 places I moved it, and I'm leaving my decimal here. Okay, I'm leaving it here. You understand why I'm leaving it here? Because if I leave it here, I'll get a between 1 and 10. In this case, my A is going to be 1.236567823. Okay, 23 into my A now is between 1 and 10. Is this number between 1 and 10? Yes, it is between 1 and 10, because 1 point something is there, isn't it? Yeah. Now, how many places you move your decimal point to the left? How many places? Again, let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places we moved to left. So that in that case, you have to put 10 to the power of 9. Okay. 10 to the power of 9. Yeah, such a big number if it is given and you have converted it into scientific notation. Okay, you may ask one thing, like here also we have so many digits, here also we have so many digits. But there is a possibility to round it off to the nearest 2 decimal places or nearest to 3 decimal places. The whole thing, you can approximate it 1.23 into 10 to the power of 9. This is as close as to this one. This is as close as to this one. Yeah, you can, as we move to the right after the decimal point, the significance of the digit reduces. So that's why you can round it off, or you can truncate some of the decimal places. Maybe you take 2 decimal places and then get rid of all other decimal places, or maybe you can even round it off, because it is 6 here, we may put 4 here. 6 is more than 5, more than half. That's why we are adding one more 1 to this number that is before that 6. Okay, yeah, this is the way. Say kg is here, don't forget to put kg, units here. Yeah, 1.24 into 10 to the power of 9. Yeah, such a big number. If you simplify it, you got it here, and if you can even further round it off, or and you get this one. Okay, yeah, that's is gonna be, yeah. So yeah, practice more and more such things, and it's very important as you take up your higher education. It's important that you don't keep writing very big numbers. Instead of that, you use the scientific notation to represent the masses, or the length, or the breadth, or the radius, or the diameter of a very tiny bodies, or very big bodies in the universe. Okay, so another kind of question that will be asked in the exam is that a number is written in the scientific notation already, and if you're asked to find out what that actual number is. For example, if I'm taking the smaller one, is something like 6.2 into 10 to the power of 3 meters. This is already written in scientific notation. Why? Because here, in place of here, we have kept 6.2, which is between 1 and 10. That condition is satisfied, and 10 to the power of n. Here we have a 3. That that condition is also satisfied. So this number, we can say it is already written in the scientific notation. If you convert that one into the normal number, what you have to do is that 6.2 into 10 cube, which is equal to 10 cube is equal to 1000. Again, don't mess up with this number, because this is most often you'll write it in your science, physics, chemistry, and all biology. Okay, so 10 cube is 1 after 3 zeros. It's not a 10 after 3 zeros. If a number is like 10 to the power of 5, 1 after you have to put 5 zeros. If number is 10 to the power of 6, 1 after you put a 6 zeros. So here we have a 10 cube. So that number, if you convert to the a normal number without any powers, you need to put 3 zeros after 1. Okay, that's called a 1000. 10 into 10 into 10. 10 times are 100, 100 times are 1000. 1000. Yeah, okay. Now you multiply these two. You multiply these two. When you multiply it, you will get, because there are 3 zeros here, the decimal places will move to the right 3 places. 6200 meters. Okay. Yeah. Yeah, on this movement of the decimal places, more and more you practice, and it's easy for you. Like the previously, when we move to the left, we put a positive number, and in this case we got rid of this positive number and we moved the decimal place to the right. Okay, that's how there is a pattern. Like if you practice two three sums, that you will get to know like how this decimal place is moving to the right or the left, and yeah. So we are multiplying with 1000. That's a positive 1000. So it's moving to the right. So it's moved 3 places, because we have 3 zeros here. It's moved 3 places to the right. Earlier it was here, move. Yeah, so I put 0 here, 0 here. So I left this one place here. Okay. Okay. Yeah. Yeah. That's how the scientific notation is very important as you move to the higher classes, say 11th class, 12th class, and even your graduation or post graduation. The scientific notation is very often used. Very often used. Okay, yeah, that's pretty much it, and we came to the end of this lesson, powers and exponents. Yep. Thank you very much for watching my videos. Thank you. Bye bye.